Hello and welcome to Vegetarian Chill with Beansy on Alphabytes Radio. I'm your host, Cassidy Ryan, here with my co-host, Jensen Almquist.
Hi everyone, welcome to the show.
Today's topic of discussion is the beautiful and technologically elegant website FODfinder. We have two special guests here with us today to talk about the technical prowess of the website. For our first guest, I would like to welcome on the eccentric JavaScript enthusiast dev for the FODfinder website, Tanner Hill. Hello, Tanner. How are you doing today?
I'm good. Yeah, I'm great. Thanks for asking.
So you did the primary programming with the API. Can you talk a little bit about that?
Sure. The FODfinder site utilizes an API from the USDA Food Data Central. It's a free API that contains nutritional information about various foods. According to the website, the API is an integrated data system that provides expanded nutrient profile data and links to related agricultural and experimental research. So basically, it provides food search and detail endpoints useful for us because it includes ingredient lists and metadata such as brand names and UPC codes.
That's really interesting. How do you incorporate this API into the FODfinder website?
Well, the ingredient information the API provides allows us to use our own proprietary algorithm to parse that information and present it in a meaningful way. Specifically, cross-referencing the information with our database to calculate the highest potential FODMAP percentage of the food and an associated FODMAP score.
Very interesting. I also hear that you use something called React on the website. Can you explain to me what React is?
Yeah, so React is a JavaScript library for building user interfaces. React replaces traditional unstructured JavaScript approaches with class-based components that manage data efficiently and respond programmatically to the UI and network events. With the ability to easily integrate asynchronous server calls, React is perfect for condensing features that would otherwise require multiple pages and all of that load time overhead.
I'm intrigued. Tell me more about how React was used on the website specifically.
A good example of this in our project is the food search page. Although the initial search query is a GET request, pagination, once the page has loaded, is handled asynchronously and seamlessly using React. It communicates with the server in the background and allows the user to quickly cycle through the results. The search features are also hooked into the React component state. And building the query through JavaScript is also done in the background. The food details page is another good example of what's possible with React, featuring dynamically loaded ingredient labeling options, a chart that utilizes Google Charts API, and a nutrition label generated based on additional data passed to the component. This shows that React is also compatible with existing JS libraries and web-based APIs.
That sounds like a seamless integration of both USDA Food Central API and React. Thank you for being on the show.
Yeah, thanks for having me.
Now I'm going to hand it off to my co-host Jensen to talk with our other special guest about the proprietary algorithm used on FODfinder.
Hi, I'm here with Gabriel Brehm, the mastermind behind procrastination and self-loathing. Gabriel, glad to have you on the show.
Hi, Jensen. Happy to be here.
I see you are the lead programmer for the FODfinder algorithm. Is that correct?
Yeah, that's correct.
Can you give me a brief overview of how it works?
Yeah, so basically it works based on the predominance of the ingredients in a food. You see, each ingredient composes a larger portion of the full food than the ingredient after it. Basically, I just figured out the maximum possible portion of each ingredient and went from there.
Interesting. Can you expand on that?
Sure thing. Let's look at an example. Check out this Orbit spearmint gum. So it all starts with the string of ingredients we get back from the API call. This has to be parsed into two separate lists of ingredient type objects. The primary list is everything that appears before the contains 2% or less of phrase, and the secondary list is everything that is after it.
And why did you choose to split the list up like that?
Well, it changes a few things. The minimum and maximum percentage of an ingredient is dependent on whether it is in the primary list or the secondary list.
Can you explain each of those cases for me?
Let's look at the primary list first. The minimum percentage of each ingredient is 2.001%, based on 10 parts per million being the lowest possible amount for an ingredient to appear on the list. The only exception to that is the first ingredient, whose minimum percentage is a little trickier to figure out, but we're going to save that for a later episode. For the secondary list, the minimum is 0.001% for each ingredient.
Such numbers. So how did you determine the maximum amount of an ingredient?
Well, the maximums are determined by the number of ingredients in the food. We can see here that in this example there are 4 primary ingredients and 8 secondary ingredients. Let's look at the first ingredient, sorbitol. Since it's the first, it must be more prevalent than all other ingredients, based on predominance. So its maximum possible percentage, which implies that all other ingredients must be at their minimum, is 94%. If sorbitol is marked as troublesome by the user, then the algorithm would determine the food contains up to 94% high FODMAP ingredients, as you can see here.
Wow. Breathtaking stuff. But what if more than one item is flagged? Say sorbitol and glycerol are both marked.
Well, then the percentage of the first troublesome ingredient is summed with the minimum of all others, and that score will be displayed for the user.
Well, it sounds like you put a lot of effort into this. Thank you for taking the time to share with us.
You're welcome. Happy to be exploited.
Thanks to all our listeners for joining us on Vegetarian Chill with Beansy. Tune in next week to hear us talk about the dining philosophers and the global pandemic. Does sharing chopsticks help the spread of COVID-19?